Good morning everyone, welcome to this lecture on descriptive statistics. I hope you guys have enjoyed the past lecture on data visualization. My name is Swazik Elise Wangson and I'm a PhD fellow at UNU Merit. 2 years ago I gave the same lecture, and I've also been tutoring the courses as well as econometrics. So the aim of this course, after you saw how you can visualize your data in Excel and in Stata, is to show you how you can summarize your data using key figure or key statistics. But before we delve deeper into what we call statistics and what are the different type of variable or how you can better summarize your variable, it will be useful if you guys can first understand the key symbols or the key mathematical property that underlie behind some of the statistical formula. So first of all, I'm going to talk about useful math signs, and then secondly, we are going to move to the different kind of mathematical property that are existing and that are very useful to compute key statistics. So if you have a variable x which is a positive integer, then the variable minus x, which has to be normally negative, is less than 0. And one of the key motivation for me to have pointed out this specific example is the simple fact that most of the students tend to confuse the order of the numbers when we move from positive to negative number. For instance, minus 5 is lower than minus 2, is lower than minus 1, and is lower than 0. So this is something that's very key and that you should understand in such a way that when you move from a positive to a negative number, the order of the number or the ordering of the different integer change. Another key concept or mathematical concept which is also important for statistics is the issue or the concept of absolute value. So here you can see the two bar, and the bar means the absolute value. So if you have a positive integer x, therefore minus x is less than 0, and the absolute value of minus x is equal to x. So this sign is red, has the absolute value of minus x. For instance, the absolute value of minus 2 is equal to 2. You also have the square root, and this will be widely used in our lecture today, but also further in other lecture and even in econometrics. So that's the square root of x. That's how you read this sign, and it's equivalent to x at the power 1 divided by 2. Therefore, the square root of x times the square root of x is equal to x at the power 1 divided by 2 times x at the power 1 divided by 2, which is equal to x. And the square root of x squared is x. For instance, the square root of 100 is equal to the square root of 10 squared, which is 10. Something also very important is the sum, the sign sum. You will see that a lot in this lecture. So this specific sign is a Greek letter, and it means the sum of x from the subscript I to the subscript n, with I lower than n. So I is a specific number of observation. So x1 can be the observation of the variable x in the observation in the person number 1. x2 is the observation of the variable x in the person number 2, and so on and so forth. So this sign means you're summing up the variable x from 1 to n being the final number. So now let's move to basic math properties. So what are the different properties that will be useful for you to better understand how we compute key statistics? So you should remember from undergrad school the PEMDAS property, as known as please excuse my dear Aunt Sally. So first, you should know that when you compute any kind of arithmetical operation, there is an order, right? So you first start by computing the figure inside the parentheses, and then you have the exponent, and there you have the multiplication and the division, and last but not least the addition and the subtraction. So here, for instance, I took an example. If you want to compute this figure, here you first start by computing the number within the parentheses, then you multiply, right? And sorry, you proceed to the division first before you multiply, and then you add. So you first start by the parentheses, and then if there is any exponent, you compute the exponent, and then you proceed to the multiplication or the division. So here you divide, and then you multiply, and then you add. So the addition comes last, and this is very key. There is an order, and this is how the order should work. And as a reminder, you use the PEMDAS. Please excuse my dear own Sally. Another basic math property, if you consider two integers a and b, the commutative property is known as you have the possibility of actually permuting two numbers that you're adding up or that you're multiplying. For instance, a plus b is equal to b plus a times b is equal to b times a. So you can actually permute the way you're adding up two numbers. The other property is the associative property. So a plus b plus c is equal to a plus b plus c, and a times b times c is equal to a times b times c. So here it means that you can actually associate that it doesn't matter, it doesn't change. So if I have three number 2, 1 and 3, then 2 times 1 times 3 is exactly the same thing times 2 times 3, 1 times 3. So it doesn't make there is no change. I can permute easily. And last but not least is the distributive property. So if I have a times b plus c, remember the priority. So the multiplication has the priority over the addition. So I'm starting by multiplying. So then I have a times b plus a times c. So this times this plus this times this. That's called the distributive property, and it's going to be used a lot in statistics in all the formula that we are going to have, be it to compute the standard deviation or any other kind of statistics. So you should remember this property very well. And if I have a negative or a subtraction here, it will be rather a times b minus a times c. So this is very important. You guys should actually frame that somewhere in your book, or so that you guys can remember that, because it's going to be used a lot, as I say. So continuing with the basic math property, you also have what we call the factoring property. So a plus b at the power 2 is equal to a plus b times a plus b. And if I'm using the different property that we cited here, so the commutative property, the associative property, but mostly the distributive property, it means I will start by a times a plus a times b plus b times a plus b times b. So here I will have a square plus 2 times a times b plus b square. And I want you by homework to find out why we move from here to here. Here what we do is we use this property here above with the commutative property, the associative property, and the distributive property to be able to have this. So this is the homework that I want you to be able to do. And then you all have the factoring property number 2, which is a square minus b square is equal to a minus b times a plus b. And then you find exactly the same answer when we move from here to here using the distributive property, the associative property, and the commutative property. We move from here to here very easily. You also have the exponent law. When you have x at the power a that you multiply by x at the power b is also equal to x at the power a plus b. This is also going to be used a lot. And if we rather have x at the power a divided by x at the power b, it is equal to x at the power a minus b. So here, one of the homework I would like you to do is use the property cited above, so the commutative, the distributive, and the associative, to compute a minus b at the power 2.